Assalamualaikum and hello. We are Group X. My name is Mia Maisara and my group mates are Erima, Edison, and Frankistine. Our presentation is titled Design and Analysis of a Multifunctional Wheelchair. To begin, I'll provide an introduction to our project. A wheelchair is an assistive mobility device used to support individuals who have difficulty walking due to aging, injury, disability, or chronic illness. These devices are crucial for people who have limited lower limb function, enabling them to maintain social involvement and improve overall quality of life. They enhance user independence by allowing movement without constant caregiver assistance and offering stable support for various environments. Though essential to their users, standard manual wheelchairs offer very limited flexibility and have been faulted as rather static. These conventional designs often lack ergonomic adjustment features such as reclining, standing, or lifting, which can limit comfort and functionality. Traditional designs may not sufficiently support users during transfers or posture changes, making independent mobility more challenging. Studies show that persons disabled and stuck in a static position suffer grave secondary morbidities, including tissue breakdown, shallow breathing, or swelling. Prolonged periods of sitting may lead to discomfort and an increased risk of pressure injuries if interface pressure is not properly managed. However, research shows that the ability to transition between postures significantly improves lower limb circulation and reduces the risk of health issues. Additionally, static positions do not permit users reach envelope, making it difficult or impossible to reach high bookshelves or engage other people at eye level without help. Our multifunctional design targets home care and rehabilitation centers, acting as a therapeutic tool that allows users to recline for rest or stand for activity. This bridges the gap between their physical limitations and the material environment. The objectives of this project are to design a multifunctional wheelchair that incorporates ergonomic features to improve user experience, to enhance user comfort, safety, and independence by including reclining, standing, and lifting mechanisms, to address the limitations of standard wheelchair designs by integrating additional posture adjustment functions, and finally, the functionality and effectiveness of the design will be validated through simulation using Working Model 2D software.
Next, I, Erima Elia, will explain the problem statement addressed in this project. The main issue motivating this project is lack of flexibility in conventional wheelchair designs, particularly for elderly and disabled users who rely on wheelchairs for long periods. Most standard wheelchairs are designed primarily for horizontal movement and do not allow users to easily recline, stand, or adjust their seating height. As a result, users are often confined to a static upright position throughout the day. From an engineering and health perspective, remaining in a fixed posture for extended periods can lead to several problems. These include discomfort, uneven pressure distribution, reduced blood circulation, and increased risk of pressure-related injuries. In addition, the absence of posture adjustment mechanisms forces users to depend heavily on caregivers even for small movements such as reclining or changing position. Another significant problem is the physical strain placed on caregivers and healthcare workers. Manual lifting and posture adjustment require repeated physical effort, which can increase the risk of injury and fatigue. This highlights a gap in existing mobility infrastructure where current wheelchairs do not sufficiently support both users and caregivers. Therefore, the core problem addressed by this project is the need for a multifunctional wheelchair that integrates reclining, standing, and lifting capabilities while maintaining safety and stability. From a mechanics perspective, this involves solving the challenge of safely transitioning the user's center of gravity during motion without compromising structural integrity or user comfort. Next, I will briefly explain the tool used in this project. The main tool used for analysis and development is Working Model 2D, which is a mechanical motion simulation software. This software allows mechanical systems to be modeled and tested in a virtual environment before physical fabrication. In this project, Working Model 2D was used to model the wheelchair structure, including the frame, wheels, and linkage mechanisms. Each component was assigned properties such as mass, joints, and constraints to simulate realistic motion behavior. The software was particularly useful for analyzing the reclining mechanism as it allowed us to observe motion control, linkage movement, and changes in the center of gravity during operation. By using simulation, potential instability and mechanical issues could be identified early, ensuring that the proposed design is safe and mechanically feasible. I will now explain the design process. The design process began with constructing a basic wheelchair frame to ensure structural stability and proper support. Once the base structure was established, additional mechanisms for reclining, standing, and lifting were integrated using linkage systems. Special focus was given to the reclining mechanism to achieve smooth and controlled motion. The design was developed through an iterative process using simulation where adjustments were made and tested repeatedly to improve performance and stability. The final design was validated through motion simulation to ensure safe posture transition and stable operation. This systematic design approach supports engineering innovation and aligns with Sustainable Development Goal 9 by promoting the use of digital tools in developing improved assistive mobility solutions.
Our simulation in Working Model 2D shows the wheelchair seat reclining smoothly and safely. Motion limits prevent over-tilting, while the standing support extends correctly to stabilize the user. No collisions occurred, and all components move as intended. These results confirm that the wheelchair design is safe, functional, and ergonomic for elderly users. The simulation conducted using Working Model 2D allowed us to analyze the mechanical behavior of the wheelchair during movement and adjustment. One key observation is that a smooth transition from sitting to a reclined position requires precise calibration of the mechanical components, particularly the pivot locations and support linkage. Improper alignment could result in a sudden motion, which may cause discomfort or instability for the user. The simulation also showed that height adjustment has a direct impact on the center of gravity. As the seat height increases, the center of gravity shifts upward, increasing the risk of toppling if not properly controlled. This highlights the importance of a stable base and controlled adjustments speed to ensure user safety. Furthermore, when the standing support mechanism is engaged, the simulation demonstrates improved user autonomy. By distributing forces gradually and supporting the upper body, users are able to perform standing-related tasks with greater confidence and reduced physical strain. Starting with the overall layout, multiple orthographic views are provided to show the wheelchair in front, rear, side, and folded configurations. These views ensure that the baseline structure remains practical while accommodating additional features without excessive complexity. The first modification is the reclining backrest, as shown in the side view and labeled in the drawing. The backrest rotates about a pivot located near the seat back junction. This recline is represented conceptually using an inclined backrest position. The recline range is intended to be suitable for elderly users, allowing comfort and pressure relief while maintaining postural stability. This feature is particularly beneficial for long-duration sitting. The second modification is the adjustable height support, which is also indicated conceptually beneath the seat area. This mechanism allows the seat height to be raised or lowered to suit different user needs, such as transfers or interaction with surrounding surfaces. In the drawing, the height adjustment is shown schematically to emphasize functionality rather than mechanical detail. This feature is important because changes in seat height directly influence the wheelchair's center of gravity. The third modification is the standing assist support, highlighted at the front of the wheelchair. The structure consists of a vertical support frame and an upper grab bar position at chest level. The standing assist support is designed to help users transition from a seated position into a semi-standing posture. Rather than enabling full standing, it reduces lower limb load and improves balance, allowing elderly users to perform daily activities with greater confidence. The highlighted lines indicate the load path and user interaction points.
Next is the discussion. The multifunctional wheelchair is designed to improve user comfort, safety, and independence by incorporating several advanced features. The three main features of this design are the reclining, standing, and lifting functions, which work together to provide enhanced mobility and support. Firstly, the main features is reclining, which allows the wheelchair's backrest to tilt backward, providing users with the ability to change their seating posture according to their comfort and activity needs. This adjustment is particularly important for individuals who spend extended periods seated, as it helps redistribute pressure across the body. Next is the standing feature, which is designed to assist users in transitioning from a seated position to a partially or fully supported standing posture. This function is especially beneficial for elderly and disabled individuals who require additional support during daily activities. The lifting feature enables vertical adjustment of the wheelchair seat by allowing users to modify their seat height according to specific tasks. This function is particularly useful during transfers, such as moving into the bed. Moreover, the reclining mechanism is given particular emphasis in this wheelchair design because of its direct impact on the user comfort and well-being. Research on reclining wheelchairs indicates that adjusting the backrest angle plays a significant role in redistributing interface pressure across the body. By allowing users to vary their posture throughout the day, the reclining function not only enhances comfort but also contributes to better circulation, muscle relaxation, and overall ergonomic support. In addition to comfort improvement, the reclining feature increases users' independence by reducing reliance on caregivers for posture adjustment. Users are able to modify their seating position independently, which supports autonomy in daily life. Furthermore, the working principle of the wheelchair relies on a complex 4-bar linkage system combined with specialized lever mechanisms to facilitate movement. To manage the seat and footrest adjustments, a tooth sector locking system is implemented. This system allows for incremental adjustments, ensuring that once a desired posture is reached. Other than that, particularly when posture adjustment mechanisms are introduced, during reclining operation, the wheelchair must ensure controlled and graded. In conclusion, the multifunctional wheelchair developed in this project addresses key limitations of conventional wheelchair designs by integrating reclining, standing, and lifting mechanisms. These features collectively improve user comfort, safety, and functional independence. The reclining mechanism, in particular, plays a significant role in enhancing seating comfort by enabling posture adjustment and reducing interface pressure during prolonged sitting, as supported by experimental findings in reclining wheelchair studies. By incorporating control motion, secure locking systems and stability-oriented design principles, the proposed wheelchair ensures safe operation during posture transitions. This project demonstrates how mechanical design innovation and simulation-based analysis can contribute to improve assistive mobility solutions. In alignment with Sustainable Development Goal 9, the design promotes innovation in medical device engineering and supports the development of resilient and inclusive healthcare infrastructure through advanced wheelchair technology. This is the end of our presentation. Thank you for watching.